Hey everyone, and welcome. Today we're going to talk about something you can't see, but that could be slowly killing your most valuable electronics. We're talking about unstable power, and, more importantly, the piece of tech designed to stop it dead in its tracks. Let's dive right in. So I've got a question for you, and I want you to really think about it. Is bad power slowly destroying your devices? And this is a serious question because the power coming from the grid, it's not always stable. You might not even notice the little fluctuations, but the damage it's doing over time, well, that's a different story. And this thing right here, this box, this servo stabilizer, could be the hero your home or business is looking for. Now, it might not look like much, just some box, right? But what it does is absolutely critical. So we're going to break down what it is, exactly how it works, and help you figure out if it's something you actually need. Okay, but before we get into the solution, we've got to understand the problem, right? So let's talk about the very real dangers that come with unstable power. So what are we really talking about here? Well, the danger actually comes from two different directions. On one hand, you've got low voltage, anything under about 170 volts. When that happens, your devices get starved for power. They try to pull in more current to make up for it, and boom, they start overheating, which can lead to failure. Not good. Then you have the other side of the coin, high voltage, over 270 volts. That's like sending a massive jolt through your electronics, frying all those tiny, delicate parts and seriously cutting their lifespan short. So, and this is the key takeaway here, this is not just some small annoyance. We are talking about permanent, irreversible damage to your expensive stuff. Your gear runs less efficiently, it just doesn't perform as well, and in the absolute worst-case scenario, yeah, it can even increase the risk of an electrical fire. This is that silent killer we were talking about. Okay, enough doom and gloom about the problem. Let's get to the good part, the solution. It's time to properly meet the servo stabilizer, your electronic guardian angel. So what is this thing? Well, the simplest way to think about it is like a security guard or a gatekeeper for your electronics. Its entire job, its only purpose in life is to stand there between the wild, unpredictable power from the grid and all your valuable gear. It takes all that messy, fluctuating voltage, smooths it all out, and sends a perfectly clean, stable, and safe supply of power to your devices. It's basically an insurance policy for anything you plug into the wall. And we're talking about incredible precision here. It's not just kind of evening things out. No, it's like a laser-focused sharpshooter. Its one goal is to nail a perfect target. Exactly 230 volts for your standard home setup, that's called single phase, or a steady 400 volts for the big, heavy-duty stuff you see in workshops, which is three-phase. It's not just reducing the bumps, it's creating a perfectly smooth road for the electricity. Okay, so that all sounds great, but how does it actually do that? Let's pop the hood and see how this system really works. All right, what you're seeing here is a pretty typical setup for a modern home or business, especially one with solar panels. And the big thing to notice is that the stabilizer isn't just some random add-on. No, it's integrated right into the heart of your whole electrical system. It works with your meter, your breakers, and, yes, your solar setup. This is super important if you have solar because it makes sure the power you're using and the power you might be sending back to the grid is totally clean and stable. Let's quickly walk through what each piece. So let's just follow the electricity for a second. You've got your meter, which is tracking power coming in and out. If you've got solar, your inverter is turning that DC power from the panels into the AC power your house can use. The MCB, that's just your circuit breaker, is your main safety switch. And right in the middle of all of it, like a traffic cop, is our servo stabilizer. It grabs that power from the grid before it gets anywhere else and makes sure it's perfect. And this whole process, it's happening in real time, all the time. It's a constant defense. So messy power comes in from the grid, the stabilizer sees it instantly. Inside, a little servo motor physically adjusts to transformer. It either boosts the voltage up or brings it down, whatever is needed. Then that perfectly corrected, safe voltage gets sent through the breaker and onto all your devices. The results? Your stuff gets the clean, stable power it was actually designed to run on. Okay, that's the theory. It sounds great on paper, but does it actually work in the real world? Well, let's take a look at a real-world example and see the proof. I mean, this quote from the case study really says everything you need to know. The magic words right there are operating successfully and reliable. This isn't just a hypothetical idea. It's a proven technology that actually delivers on its promise. And here's the data to back it up. This site had a pretty beefy 10 kilowatt solar system, and they paired it with a 15 kVA servo stabilizer. That's a powerful unit. More than enough to handle everything. But you know what the most important line on this whole chart is? It's that last one. Status, operating successfully. This thing is out there in the world, doing its job day after day. All right, so we've covered the problem, the solution, and how it works. Now for the million-dollar question. Do you need one? Let's run through a quick checklist to help you figure that out. Yeah, this is really what it all comes down to, isn't it? When does getting a stabilizer become a really smart investment for you and your stuff? Okay, here we go. A stabilizer is probably a really good idea for you if any of this sounds familiar. First, if you know you have power that jumps around a lot, you see lights flicker, or you're in that danger zone between 170 and 270 volts. Next, if you own electronics that are either super sensitive or just plain expensive. Think a nice computer, a home theater system, maybe even medical gear, stuff you really don't want to replace. Also, if you've invested in a solar power system, you definitely want to protect that investment. And finally, even if you just want your everyday appliances to work better and last a whole lot longer, it's a smart move. And that really brings us to the final question you should be asking yourself. When you think about how much it costs to replace a high-end TV or computer, and you weigh that against the hidden damage bad power is doing, the question isn't really, can I afford a stabilizer? The real question is, can I afford not to have one? Something to think about. Thanks so much for tuning in.